normality assumptions are inside XT follow a normal distribution. So most of the inferential statistics and the hypothesis testing can be valid or under the normality assumption. So assumption in performance property is the XT is not the underlying distribution quality characteristic. It's also this is associated with the quality characteristic or CTQ, critical to quality. It's normal. So if under is not normal, so sampling distribution can be derived and the exact probability can be obtained. So empirical distributions such as you can this is a log normal or exponential or approximated distribution can be derived. So there's a several, however, under the current status quo, most of them can be approximated by normal distribution. Since the data is really the data size is really big. That can be approximated by normal distribution. So有没有像阿吉仔？不断的新生。Yeah, sampling distribution R is not symmetric. So this is like this is pretty much like a geometric distribution. So thus the symmetric 3 sigma limits are not appropriate, and alpha is not exactly 0.0027. Where does this number come from? 怎么带这个充电线？来，你一定有
充电线，
对，就看
充什么？
有另外一边有 RSB， 然后再加上这个线。
这个我好像没有。我的行充只有
不是不用行充啊，我插那边的 USB。
那喜欢把膜，那个
只有这个头的，
那个
我看很少见。
那是有单面的。啊？哦，就是旧的安卓的吗？
哦，那个我没有。
对，我也没有。来借一下。厉害厉害，
太帅了吧！
然后
小叮当，
叮当百宝袋。
啊，太生气了。
哎呦，漂亮！主蜻蜓。
闪到腰是什么感觉？
你没有经验，不会问哦。
你现场闪，
你可以体验一下，
就抓出去扁。
你问一下。
你有过吗？
没有，我还年轻。是吧？我还以为是不会问。
还是我再过几年我就知道了。
帽子拿下来没那么冷了，有那么严重吗？
他肾虚，
化疗。
不用了，不用，拿下，不用，没那么冷。那你出去怎么办？头发也蛮好看的。对。Where does this number come from? 0.0027. Guys, where does the number come from? 0.0027. Where does this number come from? Then, B sigma, so the 0.0027 indicate. What does this number indicate?
这个吧，9.7。
直接先。
直接先。
Yes, please.
企业。
What does this number represent? 来，牛。
他的问题。他的问题。
0.0027. What does this number represent? Alpha, this is outside the probability outside the 3 sigma limit, right? Okay. 考试不知道，会考过吗？
Chart.
Then R chart is most sensitive to departures from the normality than X bar chart since this is not symmetric. The R following geometric distribution. So, if the if the data really deviate from the normal distribution, I will be very sensitive. So assumption of normality independence are not a primary concern in phase one. So if the data is really big, if the data is abounded, is large enough, then normality assumption is not a concern. They would like to calculate the OC curve. This is known as operating characteristic curve. It's very important. Then this is OC function. This is the beta is equal to the phi. Phi is the CDF cumulative distribution function. Yeah, you're right. So to illustrate the use of the equation of that, there is a fix. This is illustration required. How to derive? I think I illustrate this idea in elementary statistics. You have right? I think I did. You know, and we construct. L equal to 3, N equal to 5, which to determine the probability of the detecting mu equal to the mu known plus the 2 standard deviation on the, for example, on the shift. So this is the mu known, and we assume. So the mean shifted from the mu known to mu known. Yeah. So there's a true curve. Which one is a true curve? You know, the black one or blue one will be the true curve. True one? Which one is true? The blue one? Yes. since it's already shifted. So the blue one will be the true. And the black one is hypothesized, however, hypothesized one is not true. So, then we construct the three standard deviation, for example. This is, for example, the 1, 2, 3. This is the 1, 2, 3. So, in here, this is a lower control limit. This is the upper control limit. Okay, done. So Yang Ting, can you tell me, under this condition, what is the probability we make the type 2 mistake? Type 2 error.
原本它是中间应该要拒绝掉，因为它那个
Type 2 error. Actually, type 2 error means we do not reject. Instead of we do not reject, that is to say we accept. Under which condition we accept the null hypothesis? The probability under within the lower control limit. This is greater than lower control limit, and this is greater than LCL and smaller than UCL, right? Am I right? And under which curve? Blue one, right? Okay. So this. So the shaded area will be the probability we commit the type 2 error. Yeah, am I correct? 停对吗? Okay, now how can we derive? How can we derive? So that is the probability of the type 2 error we would like to derive. This is we would like to derive. Then equal to what? Let's see. Like this. So we would like to calculate this point and this point. This point. Then in terms of the CDF of the new curve, to calculate this point minus this point, the CDF, then that will be the probability. So okay, we assume this point is a flat, indicate the UCL minus 5 LCL, right? Between this point and this point. Then can you tell me this point is equal to, right on, what is this? This is a new node plus K standard deviation. Things are illustrative equation is okay, n equal to 5. So K plus standard deviation standard deviation, right? This is sigma over square root. Yeah. The sampling distribution, this is x bar. Horizontal axis is x bar, right? And the lower control limit is equal to which, gentlemen? Yes, muscle? Yes, minus? Okay, yeah, great, sigma over square root. Yeah, it's a very great, right? So we just put it inside. So we like to this need to be normalized, transformed into the standard normal distribution for calculating the probability. So this is probability. X theta is less than equal to UCL. UCL is mu naught plus K sigma square root of that, right? Okay, the probability less than and minus this, minus probability xt. No, I use the x bar. That would be good enough. I'm sorry. X bar. The less than that minus that minus less than this. Right? Is this okay for everyone? Does everybody feel good about that? Okay, what? 班长，可以吗？可以。Okay, thank you. So, then we do the normalization. So, what is the mu now? What is the real mean now? 班长 minus mean.
mu1.
Yeah, very good. Does standard deviation change? Does standard deviation change? No. Less than the mu minus plus k sigma square root of n minus mu1 divided by sigma square root of n. This is a normalization process. Minus mean divided by standard deviation minus okay. Is everybody okay with that? I think you do, right? So this is a PR. What is this? Find out. Z, right?
Yeah.
Less than or equal to. Yeah, so mu naught this should be delta. Okay. Yeah, let me see that. So L equal to 3. I'm sorry, this should be plus, I'm sorry. Mistake that. This should be plus, right? Should be plus. Okay, so okay. equal to 3. Okay, right here. Like this. So it can be derived into that. This is a cancel. So this is mu no minus mu 1 divided by sigma square root of n, right? This minus divided by this and plus k can be plus k. And the minus probability of the z less than the mu no minus mu 1, mu no minus mu 1, and minus k. Right? So the denominator can be cancelled out. Take it to that. Okay, so for this case, L equal to 3, n sample size equal to 5. Then there's a formula. Look at page 238, number 35. So there's the equation beta equal to that, and minus mu. So this is mu plus k. Yes, the mu one. So. So in here, the mu 1 is equal to the mu norm plus the k, plus delta, I'm sorry, plus the delta. So, yeah, they use delta. How much for the, they use basically. Hold on. Okay. No. No problem. Just however, I need this. Okay, the new one, the k. Okay, I use a k to indicate how many standard deviation. I would rather use this. Delta is just a shift. So delta is the size of the shift in sigma. That. So the probability, z less than. So this mu 1. So this is mu no minus this is minus delta. Minus delta. Sigma cancel out, square root of n. Perfect. And the probability, the z less than the minus delta. Am I correct? Yes. Yes, okay. Am I correct? So we just put this definition into mu1. So mu known minus mu1. Mu known cancel out. This is minus delta sigma. Minus delta sigma. And the sigma divided by square root of sigma over n. The nth flip to the numerator. Is this okay?没有问题。啊？为什么？什么江湖来？你上来指，来上来指，什么？什么？你说什么？偏移量哪有加负号？什么地方？你就把这个带进来就好了。你不要看这里啊，这个没问题。你 mu 浓，你的 mu one 等于减掉 mu 浓减掉 delta sigma， 然后这个 mu 浓消掉只剩下负的 delta sigma， 然后 sigma 消掉 square root of n 翻上来。国中数学还要问我，莫名其妙。有没有问题？添加有没有问题？真的？
应该吧。
一见，你来看，看，题有没有问题 ？Okay, done. So, in this case, how many standard deviation? 3 standard deviation we use, right? So, in which case the 3 is used. Okay, 3 standard deviation. Sample size equal to 5. Sample size equal to 5. Then, it's saying we wish to determine the probability how many standard deviation shift to, right? So in this case, we do that is equal to. Then finally, the beta equal to the 3 minus 2 square root of 5 minus 3 minus 2 square root of 5. Then can you get this number? Yeah. That is 5 minus 1.47 minus 1.47 and the minus 5 minus 7 something 737 and so how about this number minus the very negative to the left, so this is almost can be neglected since it's a minus so much to the left, so it can be neglected. So this is approximately equal to 5 minus 0.47. So finally, it turned out about 7%, 0.0708. Okay, only 7% is the type 2 error committed. Question? So this is the beta risk or the probability not detecting socket shift. So do not detect, that means we committed a type 2 error. Type 2 error is approximately around the 7%. So then this is a beta risk or probability not detect. The probability such a shift will be detected on the first subsequent sample. Instead, we like to say we able to detect it. That is a power. That is a power. So the 0.9292 is a power. We able to detect subtle shift. Then we like to say under this configuration, if what is the probability we are able to detect the shift at the fifth sample? Okay. We only able to detect the shift on the fifth sample. Can you tell me the probability that we able to detect such a shift under this description on the fifth sample we collect? Hands up. Do you understand my question? I think you do.
No.
Okay, okay. I'm gonna do that, gentlemen. Do you get my question? Yeah. That is equal to the first 1, 2, 3, 4. Fourth sample. We commit the tattoo error. We do not detect it. The fifth one, we detect it. So that is equal to the beta work times 1 minus beta. What is the beta? This. 0.07. 0.0708. 4 times 9. 9292. All right. Okay, take a break.
不知道多久。